Algebra Unit 5, Lesson 1, Notes 1, Dot Plots and Histograms. Statistics is the science that deals with the collection, classification, analysis, and interpretation of numerical facts or data. Facts involving one variable are considered univariate data. Measuring variability. Range and outliers are two measures that help us determine the spread of a data set. The range is the difference of the greatest and least values of a data set, maximum minus minimum. An outlier is an extreme value in a data set. These values are either unusually high or unusually low. Letter A. The tables below give the heights in inches of starting quarterbacks in the AFC East and AFC West. Find the range of each division and explain what this tells you about the heights of the starting quarterbacks in the two divisions. Then identify any outliers. Okay, so if we look at the East, range is largest value minus smallest value. So for the East, our range would be our larger value is 76, our smallest value is 75, so the range is 1. In the West, the largest value is 77, and the smallest value is 73. So the range in the West is 4. So let's just jot that down. East range is 1. West range is 4. Okay, that's the first part. Then it wants us to identify any outliers. Well, the data is pretty close together here. We've got in the East, we've got 76, 76, 76, and 75. Those are all really close. And then in the West, 77, 76, 73, and 77. Again, really close. So there are no outliers. So I'll write no outliers. Finally, it wants us to explain what the ranges tell us about the heights of the starting quarterbacks. So what I would say here is that since the range is so small, 1 and 4, that tells me that the heights of the quarterbacks were all really close. So let's also jot that down. Again, the heights of the quarterbacks were all really close. And I have it written right here. Let's take a look at B. The list below shows the scores on a recent math test. Determine the range of scores and identify any outliers. Now this data is actually organized least to greatest for us, which is nice. It won't always do that. So the largest value I have is 100 and the smallest is 32. So our range would be 100 minus 32, which is 68. So our range is 68. And then it wants us to determine if there are any outliers. Remember, outliers are numbers that are unusually high or unusually low. So it looks like here we've got 79 all the way to 100, and then we have this low one of a 32. We would consider that an outlier because it's really not like the rest of them. The rest of them are within 21 values of each other, and this one jumps down quite a bit. So I would say that the outlier here is 32. We'll talk more about outliers a little bit later in the chapter. Shapes of distribution. A distribution is a graph or table that shows the theoretical frequency of each possible data value. Below, there are 3 types of distribution. We have the symmetric, which is about the same on both sides. Okay, you could draw a line down the middle and it would be identical on the left and the right. And it doesn't always have to be perfectly symmetric for us to classify it as symmetric. Skewed right looks like this, where the tail end is on the right. And skewed left is the opposite, where the tail end is on the left. Dot plots and histograms. A dot plot is a plot of each data value on a scale or number line. A histogram is a graph of data that groups the data based on intervals and represents each interval by a bar. By examining or creating either of those, you can determine a variety of characteristics about the data. A frequency table is a chart used with histograms that indicates the number of values in each interval. It's very important that you know that histogram bars must touch. Letter A. Transportation officials collect data on flight delays, which means the number of minutes past the scheduled departure time that a flight takes off. Use the dot plot of the delay times for 60 big air flights during December 2012 to answer the questions below. So number 1, I'm going to let you do on your own. You can find the range. Number 2, what is the peak, or the value that occurs most often? If you take a look at your graph here, the high point, the peak, is right here. So we have 10 and 20, which means this line is 15. But it is slightly more than 15, so I would go 16. So our peak is at 16. Number 3, who would be the most interested in the information provided by this dot plot? Well, if you're talking about delays, you as a passenger wouldn't want to go with an airline that has longer delays. So really, who would be the most interested would be passengers looking to book flights. So here we will write passengers looking to book flights. And the overall shape. So if I were to draw a curve over this, it looks like I have a tail end on the right-hand side. We have our bigger portion here, and then it tapers off. So because the tail is on the right, we would say that it is skewed right. And what does the shape tell you about the distribution of delay times? So if we take a look at this one more time, we've got our delay time in minutes. So yes, we do have some that were delayed 120 minutes or 2 hours, but most of our data is around here in the lower range. So we can say that most of our delay times are pretty short. So let's go ahead and do that. Most of the delay times are short. Okay. Letter B. The histogram below shows the heights in centimeters of the students in Mr. Johnson's science class. Use the histogram to answer the questions below. Okay, we've got Mr. Johnson's science class heights. We've got the frequency, which means the amount of times it happens, and we've got their height. Note that there are ranges. So this is similar to a bar graph, except for the bars touch, so there's no space in between. And I've got intervals. Another interesting thing is I've got a break in the graph here. If I do not start at 0 with my intervals, I need to have a break in the graph. If we were to start at 0, our first bar would be right up against this line. All right, so number 1, how many students are in Mr. Johnson's science class? So what we need to do here is add them all up. So we have, in this first interval, we have 2 students. In the second interval, we have 4. And I'm looking at the top of the bars to figure out those amounts. The third interval, we have 5, then 4, then 1. So add these numbers up, 2 plus 4 plus 5 plus 4 plus 1, and we get 16 students in his class. Number 2, which interval contains the least number of students? We're looking for the shortest interval. Well, the shortest interval is right here. So our interval, we would write 200 to 209. 3, how many students in the class are less than 180 centimeters tall? Well, 180 is right here. Less than that would be everything to the left of it. So I have 4 and 2 students, which make 6. Go ahead and solve number 4. And number 5, what does the shape tell you about the distribution of students' heights in Mr. Johnson's science class? Well, if you look, they're all pretty close together. We go from 160 to 209. We have one tall student, it looks like, but generally most of the data is, in the center here, 170 to 199. That's pretty close. So we can go ahead and jot that down. Okay, the students are around the same height. Okay, these next couple questions, I'm going to start you off by helping you create these charts and graphs, and then you can go ahead and answer the questions on your own. This is just a little refresher on how to create them. I know we've done them in the past. Letter C. The list below gives the number of passengers in cars at an intersection. Create a dot plot for the data and answer the questions that follow. Keep in mind we're talking about passengers. The driver of a car is, in this example, is not considered a passenger. So that's why you're seeing some results of 0. Okay. So here we go. To make a dot plot, first it's on a number line. Well, it looks like we've got numbers from 0 all the way to 7. So let's go ahead and number our number line 0 to 7. And what we're going to do here, I like to use X's, but you can use dots. We're going to plot them as we go. So I have 3, 0, 1, 0, 2, 0, 1, 0, 2, 7, 1, 0, 2, 0, 1. Okay. And then let's throw some labels on here. On the bottom, we've got number of passengers. It's a little hard to write that neatly, so again, that says number of passengers. And I'm just going to go ahead and title this graph as passengers. Okay, again, I want you to answer the questions on your own. Letter D. The list below gives the average daily temperatures in degrees Fahrenheit for each day in February. Complete a frequency table and construct a histogram for the data. Then use them to answer the questions that follow. So here we have a bunch of temperatures. And we've got this chart, interval, tally, and frequency. So we're given the intervals. We're just going to go through our list and tally them up and then count them at the end. So here we have 39. Well, 39 falls in this range. 49, 36, 47. I like to cross them out as I go. 45, 28, 46, 38, 40, 47. Remember, when you get to 5, it's a line across. 31, 42, 33, 43, 43 again, 44, 44, 43, 33, 34, 45, 35, oops, that was the wrong one, let's undo that. Okay, 35 goes down here, 26, 37, 40, 48, 48, and 39. Okay, let's count them up. We have 2, 4, 6, 8, and 8. Now to make the graph. So we're talking about daily temperature, so I'm going to go ahead and title it Daily Temperature. And our intervals go on the bottom, and our intervals are measuring temperature. So let's label our bottom temperature. I'm going to type it this time to make it a little neater. And this is in degrees Fahrenheit, so we want to make sure we note that. I have to draw my little circle here. Okay. The left-hand column is the frequency. Okay. Did a little off-screen adjusting there. Okay. So our frequencies go from 2 to 8 if I look at the chart. Looks like I can only count by ones, so I will do that on the left-hand side. And my intervals, I've got 5 intervals, 1, 2, 3, 4, 5. So looks like I can do 2 blocks per interval. So I'm going to go ahead and label it, and then I'm going to stop the video, label it, and put it back on so you don't have to see me do it. So you can pause the video and copy down the labels. Okay, so take a moment if you have to and pause the video to copy down the scales. All right, so in our interval from 25 to 29, we have 2. So I'm going to draw a box up to 2. Okay, I'm going to go ahead and shade that in. You don't have to shade it in. Actually, let me do a different outline so it's a little more obvious. Okay, I'll shade them all in a moment. Our next interval, 30 to 34, we have 4. And I do want my bars touching because this is a histogram. And then our next one is 6. And our next one is 8. And our last one is also 8. And go ahead and shade in your bars. I guess I can try a highlighter here. Oh, maybe not. Okay. Okay. Hopefully your shading is a little better than mine. Go ahead and answer those questions. Letter E. 40 people were attending an event. The ages of the people are indicated below. Construct a frequency table and histogram and use them to answer the questions that follow. Okay, so for this one, I'm going to help you create the intervals and tell you a little bit about the histogram, and you will do the rest on your own. Okay, so we have our lowest number. Again, this looks like it's in numerical order, which is great. Our smallest number is 6, and our largest number is 97. So really, we could probably do intervals anywhere from 0 to 100. Let's see here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 intervals. Our numbers go to 100. Let's do intervals of 10. When you're creating intervals, it is very important that you do not repeat the numbers. So let me explain. Let's do our first interval from 0 to 9. So we have 0 to 9. Now remember, 0 to 9 is 10 digits, okay? You have 1 through 9, which is 9, with the included 0, which makes 10. In our next interval, we can't start at 9. We have to start at 10. If we start at 9, then when we get a value that is 9, we won't know which interval to put it in. So I'm going to go from 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99. Our highest digit is 97, so it would still fall within our intervals. Okay, so there you have your intervals. Now, I want you to notice that we do start an interval at 0. So when we graph this, let me zoom out. When we graph this, our bar will be right up against this line, okay? So against the axis, I should say. So it's going to touch, and it's going to touch because it starts at 0, and histograms don't have spaces, and that includes a space right next to the axis. Okay, so go ahead and create your histogram and answer the following questions.